10 mind-blowing facts about our solar system. Hi, welcome to Insane Curiosity. Here are 10 mind-blowing facts about our beautiful solar system. I hope you guys enjoy the video. Number 1. The currently known asteroid count is 1,113,527. Asteroids, sometimes called minor planets, are rocky remnants left over from the early formation of our solar system about 4.6 billion years ago. Most asteroids are irregularly shaped, though a few are nearly spherical, and they are often pitted or cratered. As they revolve around the Sun in elliptical orbits, the asteroids also rotate, sometimes quite erratically, tumbling as they go. More than 150 asteroids are known to have a small companion moon. Some have two moons. There are also binary, double asteroids, in which two rocky bodies of roughly equal size orbit each other, as well as triple asteroid systems. The orbits of asteroids can be changed by Jupiter's massive gravity and by occasional close encounters with Mars or other objects. These encounters can knock asteroids out of the main belt and hurl them into space in all directions across the orbits of other planets. Stray asteroids and asteroid fragments have slammed into Earth and the other planets in the past, playing a major role in altering the geological history of the planets and in the evolution of life on Earth. Scientists continuously monitor Earth-crossing asteroids, whose paths intersect Earth's orbit, and near-Earth asteroids that approach Earth's orbital distance to within about 28 million miles or 45 million kilometers, and may pose an impact danger. Radar is a valuable tool for detecting and monitoring potential impact hazards. By reflecting transmitted signals off objects, images and other information can be derived from the echoes. Scientists can learn a great deal about an asteroid's orbit, rotation, size, shape, and metal concentration. A very well-known class of asteroids is orbiting Jupiter. They are called Trojans, and you can find them around the so-called Lagrangian points L4 and L5. The term Trojan asteroid was coined when it was decided to name all asteroids discovered at the L4 and L5 points of Jupiter after warriors in the Trojan War, Greek and Trojan respectively. The exceptions are Hector, a Trojan spy in the Greek camp, and Patroclus, a Greek spy in the Trojan camp. The first two Trojan asteroids discovered and named before the two camps were established. If seen in the Jupiter rotating frame, the L5 group of Trojans seem to run after the L4 group, a group of warriors running after the other. Speaking of asteroids, number 2. We changed the trajectory of an asteroid in the solar system. It has been orbiting for the last million years. We went there, hit it, and changed its path forever. We are talking about Dimorphos, the smallest component of an asteroid binary system. The bigger one is known as Didymos. The mission designed for the job is DART, and it was sent to the system to impact the asteroid. The outcome of this collision seems to suggest the technique could work if we need to deflect a real killer space rock. Roughly 7 million miles from Earth, DART slammed into Dimorphos just after 7:14 p.m. Eastern Time on September 26th. As it hurled towards the moonlet at more than 14,000 miles an hour, the spacecraft furiously snapped images of its target. In a few minutes, Dimorphos grew from a hazy clump of pixels to an egg-shaped boulder-strewn mini-world that filled the spacecraft's field of view, growing larger and larger until the transmission abruptly cut off as the final image was coming in. Number 3. Structure. Another mind-blowing fact about the solar system is that the inner planets are rocky, but as you go further out, planets become gaseous. Have you ever noticed that? The order and arrangement of the planets and other bodies in our solar system are due to the way the solar system is formed. When the Sun was young, it was really hot out there, and only rocky material could withstand the heat close to the star. For this reason, the first planets, Mercury, Venus, Earth, and Mars, are terrestrial planets. They are all small with solid rocky surfaces. Meanwhile, materials we are used to seeing as ice, liquid, or gas settled in the outer regions of the young solar system. Gravity pulled these materials together, and this is where we find gas giants Jupiter and Saturn, and the ice giants Uranus and Neptune. Number 4. Patterns in the solar system. We all know Copernicus was right, and all planets revolve around the Sun. Kepler showed us that their trajectories are ellipses. These orbits can be described by mathematical formulas, and as such they are characterized, at least in the short term, by some nice geometrical properties. If plotted in the right reference system, you could tell they are basically part of a harmony. For instance, what would happen if we plotted the orbits of the planets relative to the Earth's position? Well, in the case of Venus, there is a highly noticeable rhythm in its motion. After 8 years, it returns to the same place in our sky on about the same date. This is known as the 8-year cycle of Venus. This cycle was already known to ancient people such as the Maya. Today, many know it as the pentagram or petals of Venus. The word pentagram is used because over the 8 years, each phenomena, each relative position of Earth, Venus, and the Sun occurs 5 times. Then over the next 8 years, they repeat 5 times almost identically. But Venus is not the only planet showing interesting patterns. Number 5. Sun-grazing comets. From time to time, some comets get really close to the Sun. They are called sun-grazing comets and have been observed for many hundreds of years. These comets were studied in the 19th century by Heinrich Kreutz. He found that all the sun grazers' orbit discovered until then all followed the same orbit. Astronomers think those were all fragments of a single comet that had broken up. The original comets had probably been broken up repeatedly as it orbited the Sun. This group of comets is today known by the name Kreutz sun grazers. But why do such comets exist? How do they come this close to the Sun? Well, solar system dynamicists seem to know the answer to that question: the three-body problem. In fact, all sorts of things happen when more than 2 bodies are orbiting under the influence of each other's gravity field. One of these is the so-called Lidov-Kozai migration. It is a dynamical phenomenon affecting the orbit of a binary system perturbed by a distant third body under certain conditions. In our case, the comet Sun is the binary system, while Jupiter acts as the perturber. In this framework, the comet is excited and perturbed by Jupiter. This changes the comet's orbital parameters, bringing it closer and closer to the Sun over long timescales. Thus, a non-sun grazer comet can become one. Thanks, Jupiter. Hey, if you are enjoying this video, you should really watch the first episode. You will find other mind-blowing facts about our solar system. Number 6. The solar system as seen from Proxima Centauri. Our Sun is actually a pretty ordinary star. I mean, it is the major thing responsible for life here on Earth, of course. But out there in the universe, it is quite anonymous. If you went out 4 light years, the distance to Proxima Centauri, the nearest star, the Sun would be readily visible to the naked eye, unlike Proxima, though nothing spectacular. And as for the planets, well, perhaps we would be able to spot Jupiter, it being the most massive one. Number 7. Future of the solar system. We all know the Sun's going to die at some point, becoming larger in size and transforming into a red giant. For decades, astronomers have wondered about the true effect of a Sun-like star death on its system of planets and moons. In particular, whether any planets can survive the onslaught. Now we have some ideas. A team from the University of Tasmania found a Jupiter-like exoplanet swirling around a white dwarf close to the center of our Milky Way galaxy. The team says the system they've discovered is a glimpse into the possible future of the solar system. While the dying Sun will likely take out the terrestrial planets, the outer planets could well survive. This is also the first time one of these planets in a similar orbit to Jupiter has been found. Number 8. We are not at the center of our galaxy. In truth, we've only been aware of the fact that we are part of a much larger disk of stars that orbit a common center for about a century. And given that we are embedded within it, it has been historically difficult to ascertain our exact position. But thanks to ongoing efforts, astronomers now know where our Sun resides in the galaxy. We know our Milky Way is a barred spiral galaxy, and the solar system, and Earth, is located about 25,000 light-years to the galactic center and 25,000 light-years away from the rim. So basically, if you were to think of the Milky Way as a big record, we would be the spot that's roughly halfway between the center and the edge. Number 9. Venus is the hottest planet. Did you know that Venus is the hottest planet in our solar system, even though Mercury is closer to the Sun? Surface temperatures on Venus are about 900 degrees Fahrenheit or 475 degrees Celsius. You have to be really careful because such temperatures are hot enough to melt lead. The surface is a rusty color and it's peppered with intensely crushed mountains and thousands of large volcanoes. Scientists think some volcanoes may still be active. Number 10. The moon is drifting away. Yes, the moon is moving away from the Earth at a rate of about 3.78 centimeters per year. The reason that the moon is slowly moving away from the Earth is due to the interaction of the moon's gravity with the Earth's oceans, also called tide. What happens is that the moon exerts a gravitational force on the Earth, which causes the movement of the Earth's oceans to form a tidal bulge. Then, since the Earth's rotating period is shorter than the moon's revolution period, this tidal bulge occurs in a position that is slightly ahead of the moon in its orbit around the Earth. This creates friction in the interior of the Earth, an energy dissipation. Part of this energy gets transferred into the moon's orbital motion, resulting in the moon being pushed to an orbit that is further away from Earth. This is the particular case of our moon, but in general, depending on some parameters, such as the period of revolution of the object, the satellite could also be drifting inwards. It seems counterintuitive and amazing, but the truth is everything is encoded in boring and very precise mathematical formulas. And that's what makes it beautiful. That's all for this video. Thanks for watching. Make sure to subscribe to the channel if you enjoyed the video, and maybe turn on the notifications. See you next time.